Hi everyone, let's do Leetcode 23, merge case sorted lists. So before attempting this problem, I highly suggest you try Leetcode 21, merge sorted lists, because this problem builds up on that one. And I have a video on this problem, so please check that out. Okay, so we're given an array of k linked lists and each linked list is sorted. We want to merge all these linked lists into a single sorted list, and we want to return that. Let's start with a simple example. So in this case, we've got 4 linked lists, and each linked list has a single node. A possible way to solve this is to take the first node and compare it to the one next to it. So in this case, let's get 4 and 9, and let's merge them so we know that 4 is smaller. So we've got 4 and 9. Now let's take the next node. We know that 5 is greater than 4 but smaller than 9. So we want to put it in the middle. This is the output linked list we're gonna get. So 4 followed by 5 followed by 9. As you saw, we had to traverse the whole linked list to get the right position for 5. Now we've got 1 left. We want to do the same thing. We know that 1 is smaller than 4. We know that 1 is the new head, followed by 4, and the rest stays unchanged. So this is our output linked list. As we saw in this example, on each new insertion we had to traverse through the partial linked list we found so far, so it's not really efficient. In fact, the time complexity for this solution is big O of k times n, where k is the number of linked lists and n is the number of nodes. So a more efficient way to solve this is to build up on a merge linked lists problem where we merge 2 linked lists. So we can use the same concept here. So we can start by merging 4 and 9 and 5 and 1. So we're going to merge the adjacent lists. So in this case, we're going to get partially merged linked lists. So 4 followed by 9. And in this case, 1 followed by 5. We want to merge these 2 linked lists. As you can see, at this point, we are at the same problem we solved in Leetcode 21, merge sorted lists. We're going to merge these 2 sorted lists. So we have 1 followed by 4 followed by 5, which is followed by 9. As you can see, we've got our output list. So in this solution, we see that to get to this stage here, we had to traverse through each node. So the time complexity was O of 1, and same to get to this node here. As you can see, at each iteration, the number of linked lists got halved. This is represented by a total time complexity of log k, where k is the number of linked lists. So at each iteration, we had to perform n operations. So the total time complexity for this solution is big O of n, where n is the number of nodes, time log k, while k is the number of linked lists. So this is better than the time complexity we saw earlier. So this is the solution we're actually gonna code. Okay, let's write some code now. So the first thing we need is to deal with the edge cases. So if lists is null, or the length of the lists variable is equals to 0, we can already return null. Next thing we want to do is take each pair of linked lists and merge them. So we can use a while length of lists is greater than 1. So we want to stop when we have our output, which is going to be 1 merge linked list. So that's why this is while length of lists is greater than 1. We want to have a temporary variable called, I'm just going to call it merged lists, and initialize it as empty. Now we want to take pairs of linked lists and merge them. So we're going to use a for loop in this case for I in range starting at 0 all the way to the end of the lists. And the incremental is going to be 2 because we want a pair. So our list 1 is going to be lists as position I, and our list 2 is going to be lists at position I plus 1. But if list is odd, we might incur in out of bounds in this case. So You want an if to check if I plus 1 is less than the length of lists. That's okay. Otherwise, we set list2 to null. That's okay as well. We can have list2 to be null because in this next step, we're gonna call our helper method, which you still need to write. So merge lists. We pass the lists to be merged, so L1 and L2. And it's okay for L2 to be none. This method is gonna return us L1, which is already sorted, and the result needs to be saved into our temporary variable, so we're just gonna append. I'm just gonna write the definition of our helper method, merge lists. So as input, we're gonna get the two lists to be merged, so we'll fill it later. So once we have merged the pairs of linked lists, we're gonna update our lists variable with the newly merged lists. After we've done all of this, we will have a single list in this variable lists, and that's gonna be our result. So we can simply return lists at position 0. So this is the main algorithm to merge k-sorted lists. I'm gonna fill this helper method. This is the same as Leetcode 21, merge two sorted lists. So I'm just gonna go through this briefly. If you want more details, check out that video, please. So I'm gonna create a dummy node. Tail is gonna be initialized as dummy. So while L1 and L2, we need to compare L1 val with L2. So tail.next is equals to L1, and we update L1 now with L1.next. Otherwise, tail.next is equals to L2. We need to update L2. And now we update the whole tail to be equals to tail.next. Now if there is any node remaining in L1, we're just gonna append it to our tail. And do the same thing for L2. At the end, we return dummy.next. So let's now see if this works. So there is a typo here. I'm missing a parenthesis. So let's try again. There is an extra bracket. So let's try again. As you can see, it does work. If you found this video useful, please like and subscribe. Also check out my YouTube channel. You're gonna find many more Leetcode questions and other videos that I hope you're gonna find useful to prepare for your technical interviews. Thank you.